Okay, so go up to File, New, and then this is our interface. So, why is it so blurry? Is that better? Oh, yeah. So over on the left, we can put pipes in, we can put tanks, we can do some other things. We can put a pump, some valves, there's a Venturi that you can put in. You can mess with that. I might have you do a Venturi when we get to a Venturi later on to remember from the first fluids. But it's actually pretty cool. So the first thing you're going to do, and I think it had you do a tank. So grab the tank and put it right here. Right? Now if you right click it, oh, you got to hit escape. So your arrow is pointing. Right click it and click change symbol for this one. It said to change this one to a river, looking river. And I think that's down a little farther. Right here. And then click OK. All right. Now, over here on the right, you can put the elevation of the river, which was what, 13 feet? Surface pressure. Well, we know that's 0 gauge pressure, right? Or it's atmospheric. Okay, but look at the unit here. See, it's PSIG. Okay. Oh wait, sorry. The elevation was, we're going to assume 0, and the liquid level was 13 feet. Okay. Sorry about that. Yep. Okay. Now, in order to understand what that is, I think if you right click, is there notes? No. I wonder if it does this. So you can change the unit if you click that button. There was something where you can actually change symbol. Look to understand what the difference between elevation and height is. Okay. So elevation is where the pipe is entering, and what we're actually doing is we're going to have the pipe at the bottom. Okay. All right. And maybe I'll find that in a little bit. Then it says to grab another tank. So grab another tank and stick it up here. Hit escape. Right click and change symbol. And this one is a closed tank. Give me a second. Come on. Yeah, it should be still recording. Yep. It's the internet here. Come on. Why isn't this working? What's that? Say that again? Oh. It's just the, there. It should be working now. Okay, so I changed that to that looking symbol. All right, it's a closed container. Now, elevation. What did I have for the elevation? What does it say on the paper for the elevation on the schematic? Yes, but we'll keep what they had, so you can try that one. That's fine. Yeah, check the actual picture. What does it say? It says 135 for the elevation. What's it say for surface pressure? 30? Okay, and then the liquid level was 15? Okay, good. So far, not too bad, right? Did you guys try this? Was this where you were getting stuck?
I just put 2 tanks in and a pipe in between, and
okay.
just put a different elevation and different higher pressure and bottom.
Okay, now what we got to do is specified fluids zones. So click System and Fluid Zones and click New. And what we're going to do is we're going to just make it a table. We're going to, if you click Table, you're going to then click Water. And yep, and it's 80 degrees, and then put 0 because we're going to assume it's basic stuff right now, okay? Because when I put 0 in, it gives us kind of what density is, and actually pound mass, 62.2. And then once you do this, click OK. And then click OK. And then click on these, and over here on the right it says fluid zone. Click fluid zone. That's the water. So we know it's water's in there. Same with this one. Fluid zone. Okay. So we got 2 tanks, the river and up there. Now we can put a pipe in, or a pump. So click sizing pump and throw it in there. Hit escape. We don't need to change the symbol, but we do have to enter some stuff. Suction elevation was what, 15? And the discharge was 15 feet? And we're going to do, if you click operation, you want flow, and what was the gallons per minute, 100? And then click OK. So now we define the pump. Now what we can do is we could actually move this pump anywhere we want here. I'm going to put it right here. Now we're going to put pipes in. So click pipe, and then click on here and there. Hit escape. Click on the pipe, and then over here on the right it says fluid zone. Click fluid, that's the water, and we're going to do length. What was the length of that one? 15 feet. Okay, and this should actually pop out. Why? That should actually give me something. So what did I miss here? Oh, yes, thank you. That is under systems. Yeah, let's check that. Let's click new. Ah, thank you. And I think we wanted what? Was it PVC? Scheduled 40? I think that's what it says. Click, oh, sizing criteria, design velocity, put 8. All right. Now I think we're good. So if you click OK, then here, specification. If you do the math, the volumetric flow rate over the speed, you get an area that matches with a diameter of 2.5 inches. Okay? So I double checked that, and actually it's in your paper. So 2.5, good. Now we can define define what's in between this pipe. So what do we have? We're going to do what they had. I think they had they had 245s on the bottom. I know I said to do 90s, okay, but I'm going to match what they have on the numbers. So if you click bend, bless you. And then there's a 45, and there's 2 of them. And then click add. And I think there was a foot valve. So I put a hinged one. Okay. You can do vertical, but look at the, see the K value, and then vertical, like 7 times more. Okay. So I just did hinged, and I clicked add. Boom. So now we have what's in that pipe. Pretty cool so far, right? Now we have one more pipe, right? And you just click the pipe, and I think you can just kind of do it like this. Okay. Over here, fluid, it's water. Specification, we're going to define it. It's going to be 2.5 inches. The length of this one, what's it say for the length? 155? 155? Total pipe length. So 140, yes, thank you. Now, what do we have? Just 90s in this one? Two of them, right? Say that again? Yep, I'll show you. When you click length, it'll give you a number. Just type the number, and when you click right here, it pops right up. Yep. Okay. So now we have that pipe defined, right? Now I think we got the tank, pressure, elevation, level. We got the pipe defined. We have a pipe or a pump that it's going to do some calculations, and then it's going to get. I'll show you. It's going to give us some best options, and we have the other pipe and then the tank. So once you have everything put in, I hope it's going to work. It worked last night. You go up to System and click Calculate, and then boom, it's already done. So it just did the Bernoulli's modified Bernoulli's equation for you. Isn't that crazy?
So it did it at least 5 times.
Yes. Yeah, at least 5 times. Now, so look at TH. That's the head. At that volumetric flow rate, you get 218. Is that what the paper says? Or pretty close? If you look at the schematic, yep, look for TH. 218, yep. So if you wanted to take these numbers that we just did here, I know I told you to do different, into that MATLAB script I just showed you, and at a volumetric flow rate of 100 gallons per minute, you should get 218 for your restriction. Okay? Does that make sense? Sort of? Yeah? Okay. So now, this is where it gets really cool. Hit escape. So now you can click on the pipe, click that, and say select catalog pump. Okay? I'm going to expand this. Now over here it says select catalog. These are different types of pumps. So like 50 means 50 hertz. 60 means 60 hertz. Okay? And I'm not sure, oh, those are turbines and the other ones are pumps, the 50 and the 60, okay? In the United States, for power, it's usually 60 hertz that we use. So we're going to click 60. And then these are the companies. And we're going to check them all. And then over here, the most common ones are 3,600 RPMs and 1,800. All right. Now, it automatically shows you with the best option right here. Okay. And it's based on, now if you look, they have the speed, they have the diameter of the blades, the head, which is 224, which satisfies what we need, right? Okay, we need 218. And then the efficiency is only 55%. Not the greatest, right? And then it gives you some other information that we kind of briefly talked about before. But now what you can do is you can actually look at this. If you double click on preview, you can look at the graph and see how much you remember. Huh? Isn't it crazy? So this is the graph that you should get with the MATLAB. Okay? Now, you see it says, let me show you if you remember. See this line right here? That's 8-inch blade diameter. This one is a 7-inch blade diameter. This one is 5-inch. Those are from the manufacturer. They make those. Okay? You see this red line straight down? That's the manufacturer's minimum flow rate. So you should have, every time you use this pump, you should have it greater than 40. Okay? This right here is on the curve. That's where they would want you to run. All right? Or is that the point at 100? That's our optimal point, desired point, where this dot is right here, where the red cross is, kind of. All right? So, if we look at this other line, see the dotted lines? Those are horsepower. All right? So let's look at, we're at 100, right, gallons per minute? So straight up, if we picked this right here, what horsepower would we be using? 5 horsepower, right? Does that make sense? Because it's the dotted lines. What inch blade would we be using? 5-inch. Now you see the green? Those are efficiencies. So what efficiency would it be? 55. Okay. But look at the head. Would it work? No. See how you read these graphs now? So if you moved up to the 7-inch, right? That would work, right? Because it gives us enough head that we need. The efficiency is slightly lower than 55. What's our horsepower? Yeah, like 12 and a half horsepower. Yep. And could we use the 8-inch? Yeah. The efficiency would be overkill. The efficiency is what? 50. So we're a little lower. We then have to use an almost 20 horsepower. But what happens when you get higher horsepower? It's going to weigh more, right? It's going to cost more. So you got to figure all that out when you do these. Pretty cool, right?